Hi again. This video is on the mole and Avogadro's number. Most of you, well, maybe some of you have heard of the mole before, and not the animal, but the chemistry mole. And how I want to explain this is that in chemistry, we need a way to relate quantities to each other. And when it comes to atoms and molecules, whether they're in your flask in the chemistry lab or in a container of some sort, there are millions and millions and trillions of molecules, and there's such a large number of atoms and molecules involved that we need a way to kind of relate this to a quantity that is more easily for us to handle, for us to understand, and for us to deal with. And so we use the mole. So just like we say there's a dozen eggs, okay, you know right away that means that you have 12 eggs. Okay, this is the same kind of thing. It's just an easier way to put a whole lot of items into and speak of them as one thing. Okay, so a mole is any quantity that contains 6.022 times 10 to the 23rd items. Okay, so think about that number, to the 23rd power, okay? That is a very, very large number, okay? So think about moving your decimal place over 23 times, okay? That's why it's easier for us to look at this as a mole, okay? This number is called Avogadro's number, okay? So if you look at your periodic table, it has been broken down and understood to us as being broken down into moles. So 1 mole of carbon atoms is always 6.02 times 10 to the 23rd carbon atoms. Okay. Now it gets even more interesting if I have a mole of water. So even if I have a molecule, doesn't matter that H2O is a compound, I still, if I have a mole of it, that means I have 6.02 times 10 to the 23rd H2O molecules. Okay? Same thing, vitamin C is a larger molecule. Doesn't matter. If I have a mole of it, it is 6.02 times 10 to the 23rd. So no matter what we're looking at, atoms, molecules, particles, ions, okay, if you have a mole, it means you have 6.02 times 10 to the 23rd items. Okay, we can use this as a conversion factor. So back in chapter 1, you learned how to convert from inches to feet or gallons to quarts and so forth. And I was particular in how you did this and how we practice, because now we're going to do the same type problems and we're going to convert. But all we're doing is using different conversion factors that you may not be used to, okay? And so we have a new conversion factor based upon what we just talked about, and that is 1 mole is always equal to 6.02 times 10 to the 23rd. So we can plug this into an equation, and it doesn't matter, depends, and we'll talk about which way to plug it in, but we can put it as 1 mole over Avogadro's number, or we can invert that, flip it over, and have Avogadro's number per 1 mole. Okay, and that doesn't matter if we're dealing with just an atom or an atoms or an element, okay, or it can be a molecule. If we have a mole of it, it's always 6.02 times 10 to the 23rd. Okay, so let's do a problem. These problems, like I said, are very similar to what you did earlier in the semester, where you just had to convert from one quantity to another. So one of the main things I told you is that you always write out what you know. You write out your number that you're given in the problem and your units, okay? And then we have to devise a plan of how we're going to use our unit factors or our conversion factors to get to the answer in the units that we want. So we're still just converting from units to units. So here's, obviously this is our video on this, so this is what we're going to be using. All right, so there's our conversion factor. Okay, how many molecules are contained in 5 moles of carbon dioxide? All right, so write out what I'm given. That's right here. And so technically, I always do, oops, 5 moles. And we're going to even write the compound, so CO2. Okay, and then I go ahead and put my sign there. Okay, so that's how I always start a problem. I write out what I'm given, write my multiplication sign, draw my fraction, and I know that if I have moles CO2 here, I have to have that same unit here in order to cancel. Okay? So with that in mind, I look at my conversion factor. I'm trying to get to molecules and I have moles. So perfect. This is a common relationship because I have a conversion factor that has moles and molecules in it. So I'm going to choose this one. Okay? Why? Okay? The reason that I choose this one is because it is in the proper orientation for moles to cancel. Okay, moles and molecules are not the same thing. Okay, so going back, here's the whole answer here, but going back to me writing this out, okay, that's what I started with. I have 5 moles CO2. I know that my moles have to cancel, so I look up here. Okay, my moles is always 1 in this example. So I have 1 mole. There are 6.02 times 10 to the 23rd molecules of CO2. So moles cancel. Here we run into calculator issues. Be sure, most calculators, you need to put it in parentheses. 5.0 times 6.02 times 10 to the 23rd. Put those both in parentheses and multiply them, and you should get 3.0 times 10 to the 24th. If your exponent is off, then your calculator is your issue, and it's a matter of learning how to work your calculator. Okay, and so our answer should be a really large number, right? Because we have 5 moles, and in every mole we have 6.02 times 10 to the 23rd molecules. So 5 times that gives us 3.0 times 10 to the 24th molecules of CO2. Okay, so now you have been introduced to a new conversion factor, okay, very different from inches and feet and grams and centimeters and all of that. Okay, and so we're going to be using lots of these, okay, and build upon these conversion factors. So here we just have one step. This is a one-step problem. Okay, and as we build through this, we'll be doing 2 steps and 3 steps, but the same idea applies. Start with what you know, write that number and the unit down, and then make sure your units cancel and you're left on top with the units that you are looking for, or that you desire. All right, I hope this helps, and I'll see you in the next video.